Hi guys, welcome to my channel. If you are new for my channel, make sure to subscribe and click the bell icon so you get notified every time we upload new videos. What is time? While most people think of time as a constant, physicist Albert Einstein showed that time is an illusion. It is relative. It can vary for different observers depending on your speed through space. To Einstein, time is the fourth dimension. Space is described as a three-dimensional arena, which provides a traveler with coordinates, such as length, width and height showing location. Time provides another coordinate, direction, although conventionally, it only moves forward. Conversely, a new theory asserts that time is real. How do we know that time travel is possible? More than 100 years ago, a famous scientist named Albert Einstein came up with an idea about how time works. He called it relativity. This theory says that time and space are linked together. Einstein also said our universe has a speed limit. Nothing can travel faster than the speed of light, 186,000 miles per second. We all travel in time. We travel 1 year in time between birthdays, for example. And we are all traveling in time at approximately the same speed. 1 second per second. What is time? While most people think of time as a constant, physicist Albert Einstein showed that time is an illusion. It is relative. It can vary for different observers depending on your speed through space. To Einstein, time is the fourth dimension. Space is described as a three-dimensional arena, which provides a traveler with coordinates, such as length, width and height showing location. Time provides another coordinate, direction, although conventionally, it only moves forward. Conversely, a new theory asserts that time is real. Most physicists think time is a subjective illusion. But what if time is real? Einstein's theory of special relativity says that time slows down or speeds up depending on how fast you move relative to something else. Approaching the speed of light, a person inside a spaceship would age much slower than his twin at home. Also, under Einstein's theory of general relativity, gravity can bend time. Picture a four-dimensional fabric called space-time. When anything that has mass sits on that piece of fabric, it causes a dimple or a bending of space-time. The bending of space-time causes objects to move on a curved path, and that curvature of space is what we know as gravity. Both the general and special relativity theories have been proven with GPS satellite technology that has very accurate timepieces on board. The effects of gravity, as well as the satellite's increased speed above the Earth relative to observers on the ground, make the unadjusted clocks gain 38 microseconds a day. In a sense, this effect, called time dilation, means astronauts are time travelers, as they return to Earth very slightly younger than their identical twins that remain on the planet. Another possibility would be to move a ship rapidly around a black hole, or to artificially create that condition with a huge, rotating structure. Black holes. Around and around they'd go, experiencing just half the time of everyone far away from the black hole. The ship and its crew would be traveling through time. Physicist Stephen Hawking wrote in the Daily Mail in 2010. Imagine they circled the black hole for 5 of their years. 10 years would pass elsewhere. When they got home, everyone on Earth would have aged 5 years more than they had. However, he added, the crew would need to travel around the speed of light for this to work. Physicist Amassian at the Technion Israel Institute of Technology in Haifa, Israel pointed out another limitation. If one used a machine, it might fall apart before being able to rotate that quickly. NASA's space telescopes also give us a way to look back in time. Telescopes help us see stars and galaxies that are very far away. It takes a long time for the light from faraway galaxies to reach us. So, when we look into the sky with a telescope, we are seeing what those stars and galaxies looked like a very long time ago. However, when we think of the phrase time travel, we are usually thinking of traveling faster than 1 second per second. That kind of time travel sounds like something you'd only see in movies or science fiction books. Could it be real? Science says yes. Cosmic strings. Another theory for potential time travelers involves something called cosmic strings, narrow tubes of energy stretched across the entire length of the ever-expanding universe. These thin regions, left over from the early cosmos, are predicted to contain huge amounts of mass, and therefore could warp the space-time around them. Time machines. It is generally understood that traveling forward or back in time would require a device, a time machine, to take you there. Time machine research often involves bending space-time so far that timelines turn back on themselves to form a loop, technically known as a closed time-like curve. To accomplish this, time machines often are thought to need an exotic form of matter with so-called negative energy density. Such exotic matter has bizarre properties, including moving in the opposite direction of normal matter when pushed. Such matter could theoretically exist, but if it did, it might be present only in quantities too small for the construction of a time machine. However, time travel research suggests time machines are possible without exotic matter. The work begins with a donut-shaped hole enveloped within a sphere of normal matter. Inside this donut-shaped vacuum, space-time could get bent upon itself using focused gravitational fields to form a closed time-like curve. To go back in time, a traveler would race around inside the donut, going further back into the past with each lap. This theory has a number of obstacles. However, the gravitational fields required to make such a closed time-like curve would have to be very strong, and manipulating them would have to be very precise. Can we use time travel in everyday life? We can't use a time machine to travel hundreds of years into the past or future. That kind of time travel only happens in books and movies. But the math of time travel does affect the things we use every day. For example, we use GPS satellites to help us figure out how to get to new places. NASA scientists also use a high accuracy version of GPS to keep track of where satellites are in space. But did you know that GPS relies on time travel calculations to help you get around town? GPS satellites orbit around Earth very quickly at about 8,700 miles per hour. This slows down GPS satellite clocks by a small fraction of a second, similar to the airplane example above. However, the satellites are also orbiting Earth about 12,550 miles above the surface. This actually speeds up GPS satellite clocks by a slightly larger fraction of a second. Here's how. Einstein's theory also says that gravity curves space and time, causing the passage of time to slow down. High up where the satellites orbit, Earth's gravity is much weaker. This causes the clocks on GPS satellites to run faster than clocks on the ground. The combined result is that the clocks on GPS satellites experience time at a rate slightly faster than 1 second per second. Luckily, scientists can use math to correct these differences in time. If scientists didn't correct the GPS clocks, there would be big problems. GPS satellites wouldn't be able to correctly calculate their position or yours. The errors would add up to a few miles each day, which is a big deal. GPS maps might think your home is nowhere near where it actually is. In summary, yes, time travel is indeed a real thing, but it's not quite what you've probably seen in the movies. Under certain conditions, it is possible to experience time passing at a different rate than 1 second per second. And there are important reasons why we need to understand this real-world form of time travel. Okay guys, make sure to subscribe and click the bell icon so you get notified every time we upload new videos. Thank you. Have a good day.